Welcome back to the podcast. Today, we're diving into the intriguing world of data models and storage engines. Whether you're a seasoned developer or just starting your journey, grasping how data is stored and retrieved is essential in our increasingly data-driven landscape. We'll touch on some key concepts, including the challenges faced by researchers and developers, the evolution of storage engines, and their impact on application performance. So grab your headphones and let's get started. In the realm of data management, different fields come with unique requirements that often call for specialized solutions. For example, researchers working with genomic data frequently perform sequence similarity searches, which involve matching long DNA sequences against extensive databases. Traditional databases can struggle with this task, leading developers to create specialized genome database software like GenBank, designed specifically for these needs. Similarly, in particle physics, projects like the Large Hadron Collider deal with massive datasets, hundreds of petabytes to be exact. Managing data at this scale requires custom solutions to keep costs manageable and optimize performance. The complexity of these tasks really underscores the necessity for databases that can efficiently handle unique workloads. Now let's talk about data models and query languages, which we've touched on in previous discussions. These elements define how data is structured and accessed. For developers, understanding how databases store data and how they retrieve it is crucial. This knowledge helps in selecting the right storage engine for any given application. Storage engines can generally be divided into two categories, transactional and analytical. Transactional workloads are focused on efficiently processing transactions, while analytical workloads are optimized for data analysis and reporting. Recognizing the difference between these types is vital for tuning your storage engine to perform well under specific workloads. Let's break down the two main families of storage engines, log-structured storage engines and page-oriented storage engines, like B-trees. To illustrate how a simple database works, imagine a basic implementation using bash functions. Picture two functions, one for storing data, called dbset, and another for retrieving it, called dbget. When you store a key-value pair, it appends to a file, creating a log-like structure. This method is efficient for writing data, since appending to a file is generally quick. However, retrieval can be a bit tricky. The dbget function has to scan through the entire file to find the latest value tied to a key, which can lead to poor performance as the database grows. This inefficiency really highlights the importance of choosing the right storage engine, as many databases incorporate logs for their internal operations. Logs are critical to database performance. They act as append-only data files that record changes over time. While our simple dbset function demonstrates the basic principle, real-world databases face additional challenges, such as concurrency control, reclaiming disk space, and error handling. Understanding how logs operate internally can provide valuable insights into how databases maintain data integrity and performance. When designing applications, performance is always a key consideration. The efficiency of data retrieval can significantly influence user experience. For instance, if every lookup takes longer as the dataset expands, it can lead to user frustration. That's why many databases implement indexing strategies to enhance lookup times, transforming what could be a linear search into a much more efficient process. As we wrap up our discussion, it's clear that understanding data models and storage engines is essential for anyone working with databases. From specialized solutions for genomic research to the complexities of handling particle physics data, the right tools can truly make a difference. In our next episode, we'll explore the trade-offs involved in implementing various data models, so stay tuned. Thanks for listening, and we hope you found this episode insightful. Until next time, keep exploring the fascinating world of data.